Hi folks, welcome to lesson 3, organic chemistry with Priestland Science. We're going to use the same lesson format as per usual, so you can pause the video at any time, collect your resources, and we'll start immediately with some retrieval practice. So pause and retrieve. Here are the answers, so you can pause, check your answers and revise. Second retrieval practice slide, so pause and retrieve. Here are the answers, so you can pause and revise. And this is the final retrieval slide, so pause and retrieve. And here are the answers, so you can pause, check and revise. Today we're going to get into the nitty-gritty of how fractional distillation actually works in the separation of crude oil. You're going to use this document, which is on Show My Homework, but if you haven't printed it, then pause the video now and copy it roughly onto a piece of paper. However, before I start the explanation of fractional distillation, I'm going to show you a very short video to get you to understand the context behind it.
Crude oil is a thick, dark brown liquid found deep in the Earth's crust. It's a mixture of different hydrocarbons, molecules made of hydrogen and carbon. Some molecules in the mixture are very small, just a few atoms joined together. Others are far more complex, with many atoms forming long-chain molecules. But as a mixture, it's useless. The different hydrocarbons need separating. The technique used is distillation. This simple apparatus is set up in a fume cupboard. Mineral wool stops the mixture spitting when it's heated. Crude oil is dropped into the bottom of the tube. A collecting bottle is put in place. And a thermometer, level with the sidearm, monitors temperature. The final step is to gently heat the mixture by immersing the tube in a hot water bath. The hydrocarbons with lower boiling points begin to vaporize immediately. They're flammable, so it's safer not to heat with a naked flame. As the vapour rises, it enters the sidearm, where it cools and condenses. This happens at about 40 Celsius. The hydrocarbons which boil at this temperature drip down the sidearm and form our first fraction. It's a colourless liquid. The temperature stays at around 40 until all the hydrocarbons with this boiling point have vaporized. The hydrocarbons left behind aren't hot enough to vaporize. Their boiling points must be higher. Once the first fraction has been collected, it's safe to start heating with a Bunsen. As the temperature rises, other hydrocarbons begin to boil. A new fraction is collected at about 60 Celsius. It's slightly yellow in colour. And so the process continues. By carefully heating the oil and collecting the liquids which condense at a number of different temperatures, the many different hydrocarbons in crude oil can be separated. This is known as fractional distillation. On a larger scale, a fractionating column is used. The oil is heated with an electric heater for safety. The vapour is condensed by a Liebig condenser and is collected in a conical flask. Hot vapour rises up the fractionating column. It's a long way to go, and the further from the heat source, the cooler it gets. Most of the vapour condenses on the glass spiral inside the column and drips back into the mixture. Only the hydrocarbons, which are still vapours at the very top of the column, enter the sidearm and condense to liquid. Industry uses the same process, but on a mammoth scale, in huge fractional distillation columns. The hot oil enters near the bottom, at a temperature of 330 degrees Celsius. The column becomes cooler towards the top. Fractions which remain as vapour at 85 degrees Celsius go straight to the top and are piped away. Different hydrocarbons condense at different temperatures, running off at various levels. Those with lower boiling points are collected at the top. Those with higher boiling points run off nearer the bottom. The longer the molecules, the higher the boiling point. Industrial distillation separates crude oil into useful fractions, each containing molecules of a similar size.
Okay, so let's break down the industrial fractional distillation into 6 steps. So here I've got what we call the flow map. I've already started to draw some of my pictures, so you might want to pause the video now and reproduce my pictures before I start drawing over the top. So pause. And I'm going to start in this top corner. So this is the start of the process. And what we have here, this is supposed to represent a pipe, and then I have a chamber, which is the shape of a square, and then I have a pipe. And what happens is crude oil is fed in at this end. And if you remember rightly, the definition of crude oil is a mixture of hydrocarbons. So I'm going to start drawing a mixture of hydrocarbons in this chamber. Now, the mixture, if you remember, is representative of the fact that they are different lengths. So I'm going to quickly try and represent that. So there we have a mixture of hydrocarbons all fairly packed together. And the first step is underneath this chamber, they will burn some fuel. It's supposed to represent my fire. And the crude oil is heated. So I'm going to write that at the bottom, crude oil is heated. Now, what we've got in the second picture, these 2 lines here, is supposed to represent this pipe here. So this is the pipe magnified. What happens when the crude oil is heated is the hydrocarbons will turn, or most of the hydrocarbons will turn from a liquid state into a gas state. So I've tried to represent that with the hydrocarbons slightly further apart. So I'm going to write here hydrocarbons evaporate. Now we have a picture to show the entire fractionating tower. Here, the pipe leading in. This is the chamber where the crude oil is heated, and then this is the pipe leading into that gigantic fractionating tower. And if you remember rightly from a previous lesson and from the video, is about 330 degrees C at the bottom, and about 85 degrees C at the top. And that's an important point. So I'm going to write that underneath. The fractionating tower is hotter at the bottom. Another word for that, if you remember rightly, is what we call a temperature gradient. So I'm just going to write temp gradient. And all that means is there is a very gradual change in temperature from 330 down to 85, and that's an even spread as you move up that tower. Now the third picture, which is actually this one, follow the arrows, we're in the right hand corner, this is supposed to represent the bottom of the fractionating tower. So the very bottom of the fractionating tower, slightly magnified. And what we have is the largest hydrocarbons, which I'm going to draw here. Those largest hydrocarbons have the highest boiling points and the highest condensing point. So when they come into the chamber, so they'll come in through here, and they will very quickly condense. If they're not already condensed, as they condense, they will sink to the bottom and they will leave out through this pipe here. And if you remember rightly, this is where we get bitumen coming out. So on the right underneath, largest hydrocarbons have highest boiling points and condense first. Now all the other hydrocarbons will start to rise, and slightly longer ones, sorry, slightly short ones, rise up the tower. But as they reach their boiling points, so they rise and they start to cool down, rise and cool down, and as they reach their boiling point, they too will condense and leave through one of these pipes. And this might be kerosene, for instance, coming out. So underneath, I'm going to write smaller hydrocarbons rise and cool, condense, at their boiling points. And finally, you probably work out what happens next is the very smallest hydrocarbons will go to the top of the fractionating column, fractionating tower, and actually they will not condense at all. Instead, they leave out at the top, and that would give us our refinery gases. So the smallest hydrocarbons remain as gases and leave through the top. Okay, so there you have it. That is industrial fractionation broken down into 6 steps. Before we go any further, this is your chance to pause the video and do some retrieval practice based on that sequence. It would probably be beneficial to do retrieval on the pictures and the words, probably separately. So do them both to get the pictures and the words into your head. And after that, we will move on to the practice question. So pause the video and do your retrieval. Okay, so here we have today's practice questions. You can do these straight from the screen, or you can print them from Show My Homework. You can pause the video and complete questions 1 to 5. And you can pause the video and complete questions 6 to 9. Now you can pause the video and have a go at questions 10 and 11. Here are the answers to questions 1 to 5. This is question 6 to 9. And this is question 10. Finally, we have question 11, which it says there's a challenge question because it comes from a different unit. It's the unit on quantitative chemistry where we're looking at calculation of moles. So have a read through there and see if you can understand that previous work. That's it for today's lesson. Thank you for tuning in, and we'll see you for the next lesson.